Yo, what it is. Okay, here I am again, all alone at school all day long. Coming at you with another awesome math video. I've got a timer set here. I'm going to go to 25 minutes, and however much I get done in 25 minutes, that's just what we get done today. That's just the way it is. So we have covered section 4.1 in your unit 4 notes. We are skipping section 4.2 since that's a graphing calculator section. And I want you to be here with me so that we can go through that together. And also, not everybody has a graphing calculator at home. So we're skipping 4.2. I'm going to try to get through the 4.3 and 4.4 today, because 4.3 is going to be very short because it's mostly a graphing section. And then 4.4 is actually a topic that you've learned before. It's a totally Algebra 1 topic. Nothing new here, just a total review of solving systems of equations from Algebra 1. Sorry. I've had some questions about homework. Don't worry about paper copies of homework right now. I don't expect you to print those off. We will only do Schoology submissions for homework assignments that we do over e-learning. I know I don't have the Schoology assignments ready yet. I just haven't been able to do it. It's not from lack of trying. I've got to get, well, whatever. I've got a lot to do here, and that's fine. We all do, but I just haven't gotten to those Schoology assignments yet. I'm going to give you time during e-learning to work on just getting homework assignments submitted. That'll be coming up soon, in fact, next week. So hang in there with the homework. Don't worry about printing it off. You can if you want to, of course. That's fine. But you're just going to be putting in answers in the Schoology assignment. You will not be turning in paper copies of the homework until we get back to school. So don't worry about that, okay? So let's get into section 4.3. And like I said, it has to do with systems of equations, and I'm not focused. Whoops, that's a light. Hey, look at that, it focused, first try, awesome. Let me make myself bigger here. There we go. Okay, I've got a lot filled out here already. I don't necessarily think that you have to copy all of this down. Do whatever you think you need to do, but really this section's about vocabulary more than anything else. All right, a system of equations is, a system consists of multiple equations. It'll have two equations here. You're allowed to have more than two, but for now we'll just have two equations. And we know that when you graph an equation like I have here, every point on the line that you've graphed, if your equation is linear, every point on the graph is considered to be a solution to that equation. So every point has an x value and a y value. That value for x and y, if you plug them into the equation, will make the left side equal to the right side. So when we solve a system, we are looking for the xy pair that is a solution to both equations. So sometimes, as you see here in example 2, if we graph the system, the two lines will cross at one point. That one point is the solution to the system. And I'm going to talk about everything that's on here. This is just basic intro stuff right now. We're not doing any graphing right now during e-learning. We're going to do all the graphing in person because you can't do graphing on the computer. So there are three possible outcomes when we graph a system of linear equations. Our systems will include linear equations, meaning when you graph them, you'll get lines. There are three possible outcomes when you do that. First of all, your two lines could be parallel, meaning they don't intersect at all, or the two lines could intersect at one point, or the two lines could fall right on top of each other. These are the three situations that we're going to consider here. If your lines are parallel, that means there is no point in common. That means this system has no solution. If your lines intersect once, then obviously there's one solution. If your lines fall right on top of each other, that means that there are infinitely many solutions. I want you to notice here that we do not say all numbers are solutions here. Okay, that would be incorrect. There are many, many, many points on this graph. There's many ordered pairs on this coordinate plane that are not solutions to this system. All of the points on these lines are solutions, but not every point is a solution. So there are infinitely many points on the line, so there are infinitely many solutions. All right, vocabulary-wise. If your system consists of parallel lines and has no solution, we say that that system is inconsistent. If your system is not inconsistent, meaning the lines do not have the same slope, then the lines either touch once or they touch a lot. Either way, we would say that the system is consistent. Consistent means the lines will touch somehow. If the lines touch at exactly one point, then we say the system is independent. If the lines touch at infinitely many points, we say the system is dependent. Now we're going to put this all together right now, and this is the part that you could probably write down. I'm even going to skip that part up here. Okay, there's a table on the next page. I'm just summarizing what I had on the other page. The lines intersect. There's one solution. That system is called consistent and independent. Those lines must have different slopes. If they have different slopes, they're going to intersect. There will be one solution. That system is consistent and independent. Coincidental lines mean that the lines lie right on top of each other. That system has infinitely many solutions. Obviously, the two lines have the same slope and the same y-intercept. That system is called consistent and dependent. If the lines are parallel, the system has no solution. The lines are parallel, they have the same slope, but they will have different y-intercepts. Notice the difference between these two cases here. If there's no solution, the system is inconsistent. Right above here, we have definitions for each of these words. Consistent means they share at least one point in common. There's at least one solution. Inconsistent mean they have no points in common. There is no solution. Independent means they have exactly one point in common. There's exactly one solution. Dependent means they have infinitely many points the same. There are infinitely many solutions. You need to know and be able to use these four vocabulary terms. Okay, that's it for this section. No, it's not. Sorry. Sometimes the system might be given to you numerically. So instead of equations or analytically, now we've got numerical representations here. We want to determine what kind of system is this. So our system consists of f of x and g of x. Here's f of x, here's g of x. Well, let's start by finding the slopes of the graphs of the two functions. Remember, the way that we find slope is we subtract the y-coordinates. Pick any 2 points. I don't care which 2 you pick. It doesn't matter. I'll pick this one and this one. Why not pick the first and second one, right? It doesn't matter which 2 points you pick. Subtract their y-coordinates, 2 minus 0. Subtract their x-coordinates, -3 minus -4. That's 2 over 1. F of x has a slope of 2. For g of x, pick any 2 points. I don't know, I'll pick that one and this one. Doesn't make a difference which 2 you choose. Subtract the y-coordinates, -1 minus 1. Subtract the x-coordinates, 0 minus 10. That's -2 over -10, which is 1/5. These slopes are different. Different slopes. If the slopes are different, the lines must intersect. There is one solution. This is a consistent system because the lines aren't parallel, and it is independent because there's exactly one solution. On to number 2, let's find the slope. Okay, I'll pick this point and this one. Who cares? Pick any two. Subtract the y coordinates, -1 minus -5. Subtract the x coordinates, 0 minus -12. That's 4/12, which is a third. Find the slope of g of x. How about we use these middle two? Just mixing it up. Subtract the y coordinates, -1 minus 0. Subtract the x coordinates, 0 minus 3. That is -1 over -3, which is a third. These have the same slope. But remember, same slope means it could be either of these two situations. We need to know the y-intercept situation. Okay, y-intercept for f of x. Remember, the y-intercept is the point whose x-coordinate is 0. So here the y-intercept is 0, -1. And here the y-intercept is 0, -1. These have the same slope, same y-intercept. That means these two lines are exactly the same. They fall right on top of each other. So there are infinitely many solutions. This is a consistent system because the lines are not parallel, they're right on top of each other. And it is dependent because there's infinitely many solutions. Last one, find the slope. I'm just going to use the first 2 points. Subtract the y's, 3 minus 1. Subtract the x's, -2 minus 1. That's 2 over -3. Okay, the other one, slope, -2 minus -4 over 2 minus 5. That is 2 over -3. Same slopes. What's the y-intercept? I don't know what the y-intercept is. I can't even see it in the table. Uh-oh, what are we going to do? Don't worry about it. Real easy to find that y-intercept. I'm going to use my slope-intercept form. I mean, it is useful for some things. It's useful because that b is the y-intercept, and the y-intercept's what I'm trying to find. Okay, I've got a number to put in for m. I need an x and a y. Well, you've got 3 x's and y's here. Just choose one. Let's pick 1, 1, because that seems like the easiest point to use. Y-coordinate is 1. Slope is -2/3. X-coordinate is also 1, plus b. And let's just solve that for b. B would be 1 plus 2/3, which is 5/3. So my y-intercept is 0, 5/3. Let's do the same thing over here. Choose one of the points. I don't know. Let's pick that first one. The y-coordinate is -2. The slope is -2/3. The x-coordinate is +2 plus b. Okay, so that means -2 equals -2 equals -4/3 plus b. So b would be -2 plus 4/3, which would be, that would be -2 plus, hold on, okay, so that's -2/3. So my y-intercept is 0, -2/3. These lines have the same slope, but different y-intercepts. They must be parallel. Therefore, there is no solution to this system. That means that this is an inconsistent system. All right, there we go. So the functions are given to us numerically. We can still kind of figure that out. On to the next section. We've got 10 minutes. Man, I can't believe I spent 15 minutes on that. I can't go any faster than that. I cannot do it. All right, next section. We're going to solve some systems here, but now We are not solving them graphically, which was the purpose of the last section. Remember, we'll do more of that when you get back to class, when we're actually able to graph again. This e-learning is just not appropriate for a math class, as I think we all know, because we can't do any graphing, but we do the best that we can. Okay, there are two ways that you learned in Algebra 1 to solve a system, and they are substitution and elimination. We're going to learn both of those methods here in this section. I would encourage you to go through and do this one on your own because it directs you how to do each method. So you can go ahead and do that and kind of remind yourself how this works. But we're going to go on to the next page here where there are no written out directions, and I'm going to go through these with you. Now, it suggests that you do each of these systems by both methods so that you can start to get a hang of when the substitution method is easier and when the elimination method is easier. And that is a great exercise to do. You need to be able to do both of these methods. I promise you, it is absolutely a requirement that you're able to use both of these methods. There are so many reasons for this, guys. It would take me half an hour to explain to you why both of these methods are important. Please take my word for it that they are. Do not just rely on using the same method for every problem, no matter what. That is a terrible idea. Sometimes one method is easier than the other, and there are things that you're going to learn over the next many years where sometimes you might need to know substitution, sometimes you might need to know elimination. Just promise me, I just promise you those things are coming and you need to learn both methods. I'm going to kind of switch back and forth here. For this first one, we're going to do the elimination method. I like to name my equations. So this first equation is equation A, and the second equation is equation B. Now, there are two legal moves that I'm allowed to make in the elimination method. First of all, I can add the two equations together term by term. So I can add the x's, I can add the y's, I can add the constants. That's legal. But when I do that, I want one of the variables to be eliminated. See how that works? You want to have one of the variables be eliminated. Right now, that wouldn't happen. I would get 4 x's and 3 y's. One of the variables was not eliminated. So the other legal move that you can perform is to multiply an entire equation by the same constant, except 0. Don't multiply by 0. That's going to wipe out the whole equation. Any other number you want to multiply is great. So here's what I'm going to do. I'm going to leave equation A alone. I'm going to keep it the same. 3x plus 2y equals 10. But I'm going to multiply equation B by -2. This is why I like to name my equations so I can write down here kind of what changes I'm making to them. So I'm going to multiply equation B by -2, and that causes it to be -2x minus 2y equals -12. And now I'm going to add these together, term by term. 3x minus 2x is x. 2y plus -2y is 0. See, the y's are eliminated now. And then 10 minus 12 is -2. And there is my x value. We need to find the y value. And to do that, all we have to do is use any equation that has x and y in it. I'm going to use equation B because it looks to be the simplest one. So I look for the simplest equation, and I just plug in the number that I got for x. Add 2 to both sides, and I get that y is 8. So I've got x is -2 and y is 8. My solution here will be an ordered pair, -2, 8. Okay? Now, let's see how we would do that with substitution. I changed my mind. I'm lesson planning in my head here as I go, but let's look at how this problem would work with substitution. And I'll remind you how that method works. With the substitution method, we're going to pick one of these equations, and we're going to solve that equation for one of the variables. So you get to choose. You can pick the first equation or the second equation, and you can solve for either x or y. It's your choice. I'm going to pick the second equation because it looks to be the simplest one. And I'm going to solve it for x. So to solve for x, that means I need to subtract y from both sides. So I can rearrange that, solve it for x, and I get x equals 6 minus y. Okay, in my next step, I'm going to go to the other equation that I didn't choose, which was 3x plus 10y plus 2y equals 10. That's the one I didn't choose in my first step. And I'm going to make a substitution. I'm going to substitute this x with 6 minus y, because I know 6 minus y is equal to x. So now this 3x becomes 3 times 6 minus y. And I'm going to recopy the rest of that equation. Plus 2y equals 10. Now I have a single equation with a single variable, and I'm going to solve this equation for y. So 3 times 6 is 18. 3 times negative y is negative 3y. Negative 3y plus 2y is negative y. Subtract 18 from both sides. 10 minus 18 is negative 8. And so I get that y is equal to 8. Now that I know that y is equal to 8, I've got my y value. I need to get my x value. For this, you can technically plug into any equation, but you should always use this one right here that you solved for that variable in the first step. So I have x equals 6 minus y, but now I know that y is 8 because I just solved for that up here. And so x equals negative 2, and there you have it again. X is negative 2, y is 8, and we got the same solution. Now, in my opinion, for that problem, elimination was easier and took less work. That's my opinion. Your opinion might be that the substitution method was easier. That's totally fine. I promise you, there will be problems for which the substitution method is absolutely the easier way to go. And there will be problems for which the elimination method is absolutely the way to go. There will be things that you learn in this math class and other math classes later on down the line that have nothing to do with systems of equations that will require you to understand this substitution method in order to learn how to solve those problems. And there will be problems that you'll learn down the line in other math classes that will have nothing to do with systems of equations that will require you to understand how that elimination method works. And so you must learn both of these methods. Do not decide on which one is your favorite and just stick to that one and do that every single time. That is a bad idea. Learn to make a decision about which method you think is easier for this particular problem. Now, you might not learn how to make those decisions until after you've practiced this a little bit. Okay, I am at 24 minutes right now. I said I was going to go to 25, so I'm going to stop. That means in my next e-learning day, I will have a very short video finishing out this lesson, which really is like 2 problems and then like 1 extra little thing. And then I'm going to let you use the rest of that e-learning day to work on getting homework assignments submitted. So you can be working on homework for section 1 and section 3. Don't worry about printing those out. You can if you want to, but you don't have to. You can just do your work on your own paper. Don't worry about graphing anything. You're not going to be putting any graphs into Schoology. Okay? I will get those Schoology assignments made as quickly as I can and get those up. But for now, just worry about getting the assignments done on your paper. And I will make sure that you have time to get them submitted to Schoology. 25 minutes flat, stopping. Bye. Have a good